In this solve-along video, we'll explore a faster way to factor quadratic trinomials with non-1 leading coefficient. And we'll do this extensively so that you'll be
unstoppable
in your exams. There are plenty of scenarios for factoring general quadratic trinomials, which is why we split it up in bite sizes so that it is much easier to understand. This is the third part, and we'll focus on faster factoring of quadratic trinomials with non-1 leading coefficient. So if you have no clue how to factor quadratic trinomials with non-1 leading coefficient, or you haven't seen our video for it yet, then be sure to click the I button. Because if you don't have that knowledge, I can guarantee that you'll be making these facial expressions watching any video about this topic. Factoring quadratic trinomials with non-1 leading coefficient is quite tedious with all of its trial and error, right? But what if I told you that you can significantly reduce the number of combinations to test for? And no, I'm not kidding! There really is a method to all this madness. You can actually make it easier using the concept of greatest common integer factors, or simply common factors. Let me show you. Any trinomial that has a greatest common factor of 1 is guaranteed to have binomial factors that also have 1 as their greatest common factor. This means that you can eliminate candidate binomial factors that have a common factor greater than 1. Let me repeat that. You can eliminate candidate binomial factors with common factors greater than 1 to tremendously reduce the amount of trial and error you have to do. Don't worry if you can't imagine how to apply the concept at this point, because I will show it to you step by step. So, on we go! There will be a 3-second countdown before I start solving each problem. You can pause the video to solve it on your own first, and then continue playing the video to see if you're correct. Alright, let's learn the faster way to factor quadratic trinomials with non-1 leading coefficient. Write the trinomial in factored form and include the blanks that we'll fill out later on. There are 2 cyan blanks for the coefficients and 2 yellow blanks for the constants. The product of the first terms in the binomials should be equal to 2x squared. The factors for this are obviously limited to just 2x and x, so let's write it down. The factors of 10 can be broken down into these 4 combinations. Fill in all the combinations of the factors of 10 in the yellow boxes. Now, this is where things become interesting. Instead of going straight to the trial and error method, we can be a little bit lazy and eliminate some of the candidate factors using the concept of common factors. First things first, look at the quadratic trinomial and observe that its terms do not have a common integer factor aside from 1. This means that the binomial factors we are looking for cannot have a common integer factor aside from 1 as well. If you inspect the second and third candidates, you can see that there are common integer factors. For the second candidate, 2x and 10 have a common factor of 2, and for the third candidate, 2x and 2 have a common factor of 2. This process allows us to eliminate candidate factors without doing polynomial multiplication. Amazing, isn't it? Now, we can proceed to the trial and error method for the remaining binomial factors. Multiply the first candidate factors. The resulting middle term is 21x. This is an incorrect candidate. Multiply the fourth candidate factors. The resulting middle term is 9x, which is what we are looking for. The final answer is 2x plus 5 times x plus 2. We were able to eliminate only 50% of the candidate factors just because this is a relatively simple example. But be sure to watch the third problem until the end, because you'll find a great surprise that will make you appreciate the principle of common integer factor even more when eliminating candidate factors. Write the trinomial in factored form and include the blanks that we'll fill out later on. The product of the first terms in the binomials should be equal to 10x squared. The possible factors for this are x times 10x and 2x times 5x. Fill in the sign blanks with the possible factors of 10x squared. Since both the middle and last terms are positive, it means that the factors of 5 should be positive as well. Fill in the yellow blanks with the possible factors of 5. Eliminate all candidate factors with common integer factors that are not 1. The first candidate is eliminated because 10x and 5 have a common factor of 5. The third candidate is also eliminated because 5x and 5 have a common factor of 5. Use the trial and error method for the remaining two candidate factors. The product of the second candidate factors have a middle term, which is 51x. This is not what we are looking for. The product of the fourth candidate factors have a middle term, which is 27x. And we have found the factors of the trinomial. The final answer is 2x plus 5 times 5x plus 1. By the way, please support Teach Me Animated Math by liking this video. And if you're new to our channel, then click the subscribe button and hit that bell icon so you get notified whenever we upload new videos. Okay, let's continue. Okay, so we eliminated 50% of candidate factors in problems number 1 and number 2. Some of you might be impressed, and some of you might be thinking,
what's the big deal? There were only 4 candidates anyway. I don't see how this can save you solving time in exams.
well, problem number 3 is much more complicated to factor. So, I'll show you how eliminating with the use of common integer factors can help you solve much faster. Write the trinomial in factored form and include the blanks that we'll fill out later on. The product of the first terms in the binomials should be equal to 4x squared. The possible factors for this are 4x times x and 2x times 2x. Fill in the sign blanks with the possible factors of 4x squared. Since both the middle and last terms are positive, it means that the factors of 24 should be positive as well. Now here comes the scary part. We've got 8 possible combinations for the factors of 24. Do you know what that means? If you substitute these combinations to the yellow blanks, we'll get a lot of candidate factors. Let's show that right now for better visual impact. Now tell me, is this list something that you would blindly want to perform polynomial multiplication on? Personally, I do not want to do that because I am lazy. And I am teaching you how to be lazy and correct at the same time. Okay, let's eliminate candidates with common integer factors aside from 1. And let's start with the left column. The first row can be eliminated because 2x and 24 have a common factor of 2. The second row also have a common factor of 2 because of 2x and 24 as well. The third row can also be eliminated because 2x and 12 have a common factor of 2. Actually, if you look at the left column candidate factors, then you can see that all rows have a common factor of 2, which means that all 8 candidates are eliminated. Now, let's move on to the right column of candidates. The first row can be eliminated because 4x and 24 have a common factor of 4. The second row is safe because it only has a common integer factor of 1. The third, fourth, and fifth rows have a common factor of 4 as well. The sixth row is also safe. The seventh row has a common integer factor of 2, and the last row has a common factor of 4. We actually eliminated 14 out of 16 candidate factors. Now, that's a lot more compared to the previous 2 problems. Easy and convenient trick, right? Let's now use the trial and error method to expand the remaining candidate binomial factors. The product of the first candidate has a middle term of 97x. Incorrect. The product of the last candidate has a middle term of 35x, which is exactly what we are looking for. The final answer is 4x plus 3 times x plus 8. Now that is how you factor quadratic trinomials with non-1 leading coefficient much faster. And here is the answer key for this worksheet. I hope you learned the faster way to factor quadratic trinomials with non-1 leading coefficient in this solve-along video. Just practice, practice, practice! The faster way to factor quadratic trinomials with non-1 leading coefficient until it becomes second nature to you. And don't be afraid to make mistakes, since correcting them is part of your learning process. Our next solve-along worksheet video is about factoring quadratic trinomials together with the GCF method. This will be just slightly harder since we're throwing GCFs in the mix. But don't worry, because our video will have step-by-step solutions that are very easy to follow. So be sure to subscribe to teach me animated math. And don't miss out. See you next time.